Okay, so here's an example using that exact same reaction as the Chem 101 problem, but slightly different numbers. So let's take a look. We have 0.1 atmospheres of HF and Kp equals 8.2, and we want to know what all the equilibrium partial pressures are given the reaction 2HF goes to H2 plus F2 is going on in this container. So again, we start by writing out the reaction that's given, so that's good. And we'll write out what the equilibrium expression is as well, so I'll write that over here. K is equal to Q. K is 8.2, so 8.2 is equal to H2 F2 over HF squared. Okay, so that's sort of our first thing always. Then we want to write out our ice table, so I've got I, C, E. Notice this problem, we're in atmospheres. This is a Kp, so we can use atmospheres just like we would use molarity. So 0.10, 0, minus 2x. Remember, we have to take account of that coefficient. Plus x, and then our overall equilibrium row here, 0.1 minus 2x, x, and x. Okay, next we're just going to plug into k equals q here to see what equation we need to solve for. So I'll write that out. 8.2 is equal to x, and then hf down here is 0.1 minus 2x. So 8.2 is equal to x times x over 0.1 minus 2x squared. Okay, now we get to the really important chemistry part of this, is this guess piece. So because K is about 8.2, remember K is close to 1, so we're going to have similar amounts of reactants and products. Now, what that means is that we don't expect this small x approximation to work really well. If it does, that's always generally the easiest way to solve these. But in this case, K is big enough that we expect this is probably not going to be a great method to use. That's going to lead us to those other solution methods. So if we can solve exactly, that's a good way to do it. In this case, the exact solution, in this case, that actually is an option. If you look at this equation, we have a square on the top and on the bottom. So like we did an example in class, you could sort of square root both sides and use that to go directly to the answer. We're not going to show that one. That's sort of a trick. It doesn't always work. So the example I'm going to use is quadratic, use that way to solve this equation. We could also use successive approximations like I showed in the video for Monday, or if you have your solver and your calculator at this point, you could certainly easily plug it into the solver. I would definitely recommend that. Okay, so here's our general way we can solve quadratics. First, we get it into the form ax² plus bx plus c is equal to 0. And then we use the quadratic equation, or the quadratic formula, which is this. The value of x that solves that equation is negative b over 2a plus or minus b squared minus 4ac over 2a. So that'll give us two values of x, and then we need to choose the one that makes sense. So the key is that we can never have any negative concentration or pressures. Often that means the positive value of x, but not always. Sometimes there's two positive solutions. We just have to check both of them and make sure we choose the correct one. Okay, so let's see how this works in this case. We've got 8.2 equals x times x over 0.1 minus 2x squared. So first I'll do 8.2 is equal to x squared over 0.1 minus 2x squared. Now, the first thing I need to do is get all this stuff from the denominator over to the other side. So I'll multiply both sides by 0.1 minus 2x squared. Now the next thing I need to do to make it look like ax² plus bx plus c, I'm going to expand all of this to get, Okay, so just a review of, expanding this out. I can do this using FOIL and recognizing that 0.1 minus 2x squared is just 0.1 minus 2x, 0.1 minus 2x, and then all that times 8.2. And okay, then the four terms again, first is this first one, so that's first, and then outer is this term, inner is this term, and then the last one is going to be that one. So I'll write those four terms out. I'm going to leave the parentheses on here because I'm going to still need to multiply everything by 8.2 at the end. So 0.1 squared is the first term, minus 2x times 0.1 is outer, minus 2x times 0.1 is inner. And then the last term, minus 2x times minus 2x, when I take negative times negative, I get positive, so plus 4x squared is the last term there. All that times 8.2 is equal to x squared. So next I'll sort of simplify the FOIL stuff there that I multiplied out. That's 0.01 minus 0.4x plus 4x squared. All that times 8.2 is equal to x squared. So now I'll multiply by 8.2. So 0.082. Remember, I have to distribute that across every term here. So that's 8.2 times 0.01, 8.2 by 0.4, and 8.2 by 4x squared. So 0.082 minus 3.28x plus 32.8x squared is equal to x squared. Then the last thing I can do is just subtract x squared from both sides. So I get 0 on the right-hand side. So minus x squared minus x squared. That gives me a final form here of my equation, which is 31.8x squared minus 3.28x plus 0.082 is equal to 0. Now this is finally in the form ax squared plus bx plus c is equal to 0. And so I can identify here that 31.8 is equal to a, b is equal to negative 3.28, remember the negative in there, and c is equal to 0.082. Okay, now I can plug in x equals negative 3.28 times negative, so that's positive 3.28 over 2 times 31.8 plus and minus b squared, so that's negative 3.28 squared minus 4 times 31.8 times 0.082, just fitting that in there, over 2 times 31.8. And when I do that, I get the following values for x. I get 0.0515 plus or minus 0.009. And so then the two values of x I get are, okay, so my two values of x, 0.0426, I looked at my calculator again, I rounded incorrectly before, 0.0426 or 0.060. Then I plug into my equilibrium row. So if x equals 0.0426, what values do I get for each of those three concentrations? 0.1 minus 2 times 0.0426. I get 0.0149 molar for HF, and I get 0.0426, which is really going to be 0.043 for H2 and F2. And if instead I had x equals 0.06, we're going to get a problem in that very first one. 0.1 minus 2 times 0.06 is negative 0.02, and this is impossible. So because this is the negative concentration, so again, that negative pressure concentration means that our actual value of x is 0.0426, and these are the concentrations of our three substances. If I just rewrite those in a nice table, I get this table right here. H2 equals F2 equals 0.043, HF equals 0.015, just checking that this makes sense. Again, remember for this equation we had K is equal to 8.2, so expect similar amounts of reactants and products, and that is what we have, right? None of these are hugely, it's not like one of these is 0.0001 and the other one is really huge, we have roughly similar amounts of reactants and products at equilibrium. So this is the correct answer here, using the quadratic equation to solve for x.